Welcome to tonight's webinar, everyone, which was inspired by new programs and messaging from the BC government and industry about the industrial logging of natural forests that have experienced a recent natural disturbance. Thank you so much for joining us. Tonight's event is co-sponsored by the Interior Watershed Task Force, a citizens coalition in the Okanagan advocating for clean water, natural forests, and wildlife habitat, the Fraser Headwaters Alliance, a volunteer-based organization advocating for sustainability in the Fraser Headwaters bioregion, and WildSite, an environmental NGO defending wildlife, water, and wild places in Canada's Columbia and Rocky Mountain regions. I'm Michelle, and Kate Logan and I are with Conservation North. We're a volunteer group based in Daketh lands in north central BC, and we advocate on behalf of primary forests, which are forests of any age that have never been industrially logged, because this is the first and most important step to address massive declines in wildlife populations and biodiversity in general. Tonight, we will first hear from 3 speakers, who I'll introduce in a minute. Then we will have a 5-minute break. Then we will hear from the last 2 speakers, followed by a short Q&A. Please put questions in the Q&A box and indicate who you would like the question directed to. Our first speaker is Seraphine Munroe, who is Daketh and Stalo. She serves as a strategic advisor and provides technical support on Indigenous forest management. With a deep commitment to addressing the cumulative effects of large-scale logging practices, Seraphine works to ensure that Indigenous perspectives are integrated into forest management, especially in the context of changing governing systems. After Seraphine, we will hear from Dr. Karen Price, who is an independent ecologist based on unceded Wet'suwet'en territory. She has worked on old growth and land use policy for 25 years, aiming to bring science and transparency to decisions. Karen focuses on how to maintain ecological resilience given cumulative effects of management and climate. Her peer-reviewed publications address old growth species from epiphytic lichens to stream insects and birds, forest structure, and the status of BC's old growth. Thirdly, we'll have Dr. Phil Burton, who's an emeritus professor with the Department of Ecosystem Science and Management at the University of Northern BC. His research has focused on vegetation dynamics associated with the disturbance and recovery of BC forests following natural and human disturbances, resulting in the publication of more than 100 journal articles and book chapters. He was co-author of the 2008 Island Press book, Salvage Logging and Its Ecological Consequences. With that, I will let our first speaker, Seraphine Munroe, have the screen.
Hey everyone, thanks Michelle for that lovely introduction. I'm just going to go ahead and share my screen here now. All right, so I'm just going to go ahead and go on with my presentation titled From Trees to Forests, Transforming Western Forest Management Regimes with Indigenous Perspectives. This is a special presentation for Conservation North and for all of you today to give a little bit of perspective as we are operating within the Daketh territory. And within that context, they have brought me on board to give a round or high-level introduction on some of the work that I do, as well as who Daketh people are within the work moving forward and developing initiatives. So thank you for having me. We'll move ahead to talking about what is it that we're going to talk about today. So a little bit about me, the Daketh culture, our Keyos, the Colonial project, values and contrasts, as well as what it means to create a paradigm shift. Moving ahead, so why me? I ask myself this question every day. No, just kidding. I am Daketh and Stalo First Nations. I was raised at the negotiating tables in the context of the politics of land. I have a background in archaeology and forestry. I am also a registered professional archaeologist and a current advisor and technician supporting collaborative stewardship models in BC. So I did mention that I was Daketh. I was raised primarily Daketh, and just wanted to give a bit of a insight on who Daketh people are. So one, we're not a homogenous group of people. We're culturally diverse and regionally specific, where stewardship and governance has occurred through clans, Keyos, or a combination of clan and Keyoh governing systems. We were displaced from our lands through the Indian Act, like many Indigenous groups across Canada, with the establishment of Indian bands and residential schools. And subsequently, a lot of our lands have also been parceled out by privatization or trapline systems where some, like in the cases of mine, were registered as KOs and others were parceled out. So looking at DACA stewardship, just briefly, I can't go into all of the laws in detail, otherwise I'll be here for the entire day or more. It is an area of responsibility. Like tenure, it is a hereditary system with a leader that is held by a family group. Laws are built with a long-standing relationship to the land, and in most places across DACA territory, KO is an active part of DACA governance and stewardship. How is it that we operationalize our KOs today in stewardship? So many families that you'll see within our territories continue to actively use and steward their lands. We are blessed to have been raised, so within my context, intergenerationally with our grandparents and our communities, and with my grandparents who are language speakers and knowledge keepers. All of our free time was spent on the land, hunting, fishing, trapping, berry picking, just existing as a family. Like many Indigenous people living with these social impacts of colonialism, the bush has provided refuge. So with the social perils that plague our communities, and the cycles of violence that happen as a result of poverty, and being on the margins of society, the bush was always a safe space. And our KO is like like my grandma had always said, the KO is like a magnet always calling me home. So, you know, this really sparks core memories for me growing up for when things just became too overwhelming in town. For my grandmother, she would just call up my grandpa and be like, hey, Dixon. Dixon's the one that you see on the cell phone there. He's a modern grandpa, that one. He always gets mad at me if I don't answer his FaceTime calls, actually. But so that's my grandparents that you'll see there in that photo, and me driving the boat down below. But she would just call him up and, you know, things would get overwhelming. It didn't matter what time it was. It was Friday night at 10 p.m. and she would load all of us kids up and get in the truck and we would head on to the RKO and to the bush, and we would skidoo into our cabin, and we wouldn't arrive to our cabin until 2 in the morning sometimes. And I remember just being like bundled up in the back of a skimmer. So, you know, land was always a place for like a safe space for all of us to continue to again, like I had said, just exist. However, you know, I think as part of this talk, I really wanted to just give a little high level description as to the disruptions within our way of life over time. It's really inorganic the way I'm talking about it right now, because I'm just really diving into like really deep levels of colonialism and stuff within family, and how that has resulted to trauma and disconnection, and what does that really look like within colonialism and forest management systems. So this machine is really about disconnecting humans from landscape and how that has been developed and evolved over time off of a set of objectives and values as a part of the colonial project within Canada. And so what is the result of that? So looking backwards, this is an aerial shot of my KO. This is before I was born, but relatively intact forest landscapes. You know, we didn't have too many clear cuts, or clear cuts were small forest policy at the time. Wasn't necessarily developed off of a social reliability model like we see here, where it's volume incentives and things like that. This was more localized control of forest management, and I mean, rather still exclusionary based on the racism, with systemic racism that we had seen historically within Canada. We weren't necessarily a part of those conversations, but we've always been here on this land, participating within local economies and being, you know, a lot of our jobs are really placed within the forest system. So anyways, back to this is a relatively untouched landscape, and I had grown up till, you know, a turning point about 1998, where we had seen mass large-scale deforestation within our territory. So when I was young, I used to see a moose on the lake every single day, to seeing a moose on the lake maybe luckily once every summer, so where our cabin is. And over time, I am lucky to see one once in a summer. And a lot of this has really resulted out of the, you know, the cookie cutter, like how the land just has been really disconnected over time, and then created access and over harvesting of all of its resources, including its animals. So that was around 2016 when I went back to school for my master's in forestry and taking a look at forest tenure. And then this is a shot around 2022. Most of the areas in our Keyoh is burned. Wherever it's not logged, it's now burned. And, it's also part of the conversation in the network that I've made those connections with people here that you see, such as Michelle Connolly with Conservation North, with these really important topics that face our communities. And just giving some varying perspectives to the conversation that really inform how we do our work within our local environments, as I assume many of you are within those kinds of capacities. So here, as I had said, so this is an outdated aerial shot. A lot of this, the remainder of this, about 90% of our land is impacted. It's similar to what the Blue Ray River case and the cumulative effects assessment, which really had said that it's death by 1,000 cuts. And so when we move ahead, like on a higher level, so this is the spatial boundary of the Carriacicani First Nations. I would like to show this time-lapse video to show what significant level of impact that has happened over time within a relatively short amount of time. Like it was very condensed in the last 20 years within my life, that I'm one of the last generations to be able to walk on our trails, to hear my grandmother's story, to live in an environment in which we were able to operationalize our culture that was looked at the land much in a way that our ancestors were able to. So disconnection has happened at a rapid rate, and youth today are faced with a lot more challenges in order to create access. So speaking of access, the residual impacts of mass deforestation within the territory has meant that we've had tons of roads. So Neckasley, the band that I'm registered to, has over 2.7 million cubic meters of road networks alone. Or if you were to line them up end to end, it would cover 3/4 away around the earth. And then you have also just one conservation officer. I think his name is Steve or something. Sorry, Steve, but calling you out. But what I'm saying, trying to make a point here, is that we have an unlimited amount of access across the landscape that has really shifted and disrupted the way that we use our lands as Dakas people, as well as provided huge amounts of access for other people and predators, or maybe they're also one and the same, as we're thinking about, access to resources such as moose, other game, birds, wildlife, fish. And with the culture of Canada that we live in right now, we're still in a cowboy mentality in which the land is free for the taking. And so these are largely unregulated areas and zones that don't have proper stewardship mechanisms on a local level. And that's what I'm here to kind of talk about today, about how we need to really localize stewardship regimes and management as we're thinking about that paradigm shift in forest management altogether. So again, impacts of disconnection. What does that really look like in reality? It means this disruption on family dynamics. It exacerbates social conditions. There's impacts on relationships and communities. It fosters competition, accelerates loss of language, and culture. So culture and language are very much the same. So overcutting directly impacted our family dynamics and cultural continuity with mismanagement. It further forces people into poor social conditions, because when we have less and less of that space of refuge and/or space that people are competing for, because there's less resources and we're still largely faced with a lot of barriers, including poverty. And it also costs money to go to the bush too. Like, to go hunting, you have to have a lot more wealth in order to access the land, because you have to work a lot harder for the moose or for the animals that you're hunting for. So it's not as plentiful. And so it creates it fosters a scarcity mindset within our communities that is also further fueled and pervasive as a result of the Indian Act. Whereas in contrast to that, traditional wealth was really measured by how many people we could feed. Further to that, our stories are place-based. They're tied to the land, and in our family-based territories, the impacts of logging can disrupt the traditional lifestyles. So if those areas are gone, and we're moved off and we're not participating in the same ways that we were, such as using trails and over roads and those kinds of things. It has meant that the loss of land and culture, again, continues to marginalize us and our people. We are a part of the land, and with that, we have an innate sense of responsibility. So there's the health of the land that's connected to the health of our people, and therefore the loss of our language that's tied to the loss of land. So what I'm getting at with this is that, again, when we don't have those cultural markers intact as a part of our forest system, and we don't have things that signify to us to sort of tell those stories, and we're not walking on those same trails, it also erodes our ability for cultural revitalization, such as language. And language really carries our laws. It's the way that you see the world, and it's very much culturally informed. And so, for example, I give this example all the time around what does the word even keyoh mean? So ke being like the root word for like ke chan for your feet, and yoh being your rib cage. It's like the land that holds you. So these are like descriptors that are made from the land in which that we recognize, and how we relate to one another. Or ke chan, which ke being feet, again, chan as a part of root word for chandu, which means forest. So ke chan, which means like it is the word for leg, and leg is the part that connects you to your land. So that's just a really brief description of some of these impacts. So to this point, I wanted to share a little bit about my experiences growing up on the land, why I went to school, working at various levels. I do work a lot at various levels of Indigenous governance, including my own. And this has all allowed me to understand the social impacts and implications of the ways in which, if we disregard engagement with Indigenous people, it eventually leads to harm, and not just harm for Indigenous people, but harm for everyone. Because we see the real life repercussions of this in the midst of climate change, the forest sector that is dwindling, and how we want to look forward and manage for more than just profit, how we want to manage for people, and people for generations into the future, right? We all call this place home now. So there's that sense of responsibility that can be derived and lessons learned from Indigenous values, laws, and practices. So I did talk a little bit about the Colonial project a bit. So the impacts of large-scale logging was built off the premise of the Colonial objective, which was really about building laws that created and maintained unfettered access to the land for the purpose of extracting and exporting wealth. And it was really about power over and based on the values of what land was deemed to be used as. So it was a way of delegitimizing Indigenous ways of knowing and managing, because we weren't using the land in the proper form of what civilized people were, what they would deem to be full utilization, which implied ownership. So again, very high level descriptor of what Colonial project means in the context of forest management. But right now we are at a the current conditions has put us in a bit of a shift where BC has recognized Indigenous rights and titles to the land, their right to manage the land according to their own laws, such as DRIPA. There's various efforts being made to work with First Nations to address socio-environmental conditions that are collaborative, are done through collaborative management efforts, through such as reconciliation agreements and other landscape level initiatives. So we are at the start of a cultural shift in BC, but while change is in place, great efforts are still made to ensure stability. And however, maintaining stability is not without its challenges. It often means maintaining the status quo, which can lead to exclusionary policy reform and further disconnection. So salvage logging in this context is really a part of that streamlined approach that builds efficiencies for stability that seeks to capitalize on small windows of value. But again, when we're talking about value, like value for what? Value for whom? And value for the land? Is it for its people? Which people? So those kinds of questions are the things that I often think about when I'm evaluating new policy initiatives and legislation within BC, and or how those things operationalize in the development of collaborative approaches. So it can be like, if we're not thoughtful about those things, this approach can end up being myopic and lead to further harms and impacts. So why does Indigenous values matter? So how do we create that paradigm shift? Values are everything. Indigenous values are about taking only what you need. They are reciprocal. You only give what you give what you take, or you give as much back into the land as what you take. So we have to be thoughtful as when we're taking, like, how are we restoring as well? How are we giving back to it? I was recently a part of a ceremony down south where the collaborative group had organized a harvest ceremony, so to give respect and gratitude for the trees and what they're offering back to us. So there was like a significance around that. And I think those like social practices reinforce that level of social accountability in how we see land, and see land for more than just like wood and a 2x4, for instance. Again, they're built on relationships, which creates and fosters a sense of responsibility, not just for the land, but for our non-human relatives and its inhabitants. So I had recently heard an elder say to me that the reason we have to speak for the trees, or why we have these kinds of laws in place, is because, you know, when we're thinking about fires and fires that come through, and the way that we made our forest management systems and how we manage forestry prior to contact was again about resilient landscapes. And we're always thinking like with an Indigenous scientific lens around what is it that's going to support us generations into the future. So again, not taking more than you need, but at the same time thinking about like our non-human relatives, such as trees and moose and all those things. And she had said to me, while moose and other animals can run away from fire, trees cannot. They are there to stay. So that is what makes them so much more vulnerable. But at the same time, it's also what's made them more adaptable. So, you know, they have adaptive systems in place for that reason. So, you know, certain trees grow a certain type of bark that makes them more resilient. They make and build relationships with other trees of deciduous classes that build resiliency and their ability to resist fire, things like that, and make them like resiliency, meaning they can bounce back faster. So again, moving forward, I know I'm at 20 minutes. I'm so sorry about that. You know, I just on the top of my mind as to what collaboration may look like. It's really about starting at a local level with recognition and giving grace to nations. Bans on all fronts, like First Nations communities face enormous barriers, capacity challenges, governance, and systems that were never designed to manage land. It was designed to manage poverty, to be frank. And at the same time, because they weren't our own systems, and we're really working hard internally to change that and to make the space, you know, for recognition and operationalization of our laws, like such as our KOs, that it does still embody and retain the values of the colonial state because it comes from the Indian Act. So we're shifting at this, like simultaneously, we're also shifting out of poverty and gaining equal access to, you know, similar to that of settler populations. So we have far less resources and ability to start doing collaboration within a timeline that meets the goals and objectives of where BC's timelines are at. So again, we really need to create space and continued awareness of recognition of Indigenous laws, because our laws never cease to exist just because Canada put their flag here 150 years ago. They are underground, but they're alive, and they are alive with our people and our land. The land at the same time needs to heal with our people, and cultural revitalization can only occur with the revitalization and rehabilitation of the land itself. So we are at this place where we really need to think about the importance of interdisciplinary needs to support innovative approaches to creating resilient forests. And I think that like having supports for multidisciplinary knowledge frameworks like this at the precipice of climate change in managing these real world impacts to our local communities, not just Indigenous ones, is really key. And I think that's what the value in having these types of knowledge sharing forums and panels, what really offers in creating access to people who otherwise may not have had that. So for that reason, I just really wanted to thank Conservation North and all of the work that they did to get us all here together today to share with all of you today. So thank you so much for having me. And that's the end of my talk.
Masi, thank you so much, Seraphine. Our next speaker will be Karen Price, Dr. Karen Price. Karen, will let you have the screen.
So at first, I'd really like to thank Michelle for bringing us all together to discuss this issue. And also, I'd really like to thank Seraphine for giving us such a great introduction to the colonial basis of this machine that has separated us all from the land and that has led to all of the harms that we're seeing today. So I'd like to pose the question, should we salvage, always in little quotes, harvest in an era of crises? Next slide, please. We're living amidst climate and biodiversity crises, not just globally, but also in BC. We're seeing floods and fires. The background picture is taken as we're evacuating from land that burned last summer. We're seeing populations and species winking out. Let's think caribou, spotted owl, moose declines. And nations are struggling with food security. Next slide, please. So in these times, we need to be able to support biodiversity, store carbon, and adapt to climate heating. Next slide. So let's ask, does post-disturbance harvest support biodiversity, store carbon, and adapt to climate heating? I'm going to cover this from a Western science perspective and go over some high-level evidence for each one of these in turn. I'll use BC evidence as much as possible, and where not possible, I'll go with Western North America and some meta-analyses that cover the globe. So let's start with biodiversity. So the perception here, amongst many, is that disturbed stands have lost their ecological value and that we need to restore them. We need to do something. So as Michelle mentioned, the provincial government has put out a press release talking about wood recovery from fires that uses words like land recovery, restore area for wildlife, nurturing renewal. These are all like really nice, friendly, positive words. Next slide, please. However, the reality is that stand level disturbances characterize many of BC's ecosystems, and that disturbed primary forest, also called natural young forest, is valuable for many reasons. Next, please. Disturbances create structural legacies in the form of patches of live trees, dead standing snags, and downed wood. The graph in the middle is from some data from BC, and we're looking at how many stems there are per hectare, and the dark bars are dead and the other ones are live. And you can see that after fire, there's a lot of dead snags standing. After beetles, there's dead and some live. After wind, there are a few less standing, and there's a lot of downed wood that's not shown on the slide here. Importantly, these legacies provide a structural complexity that is an integral part of the stand as it ages, providing continuous habitat through the whole succession. And dead trees, actually, from an ecological perspective, are often have more value than a live tree. Next slide. At the stand level, disturbances increase diversity. There's variability within and between disturbances that create a mosaic of ages and ecosystem types across the landscape that create the resilience that Seraphine was talking about and refugia at multiple scales. Next slide. So even really intense fires, this is the Shovel Lake fire. It covered about 100,000 hectares, and it was really difficult to control. It was a severe fire. And if you look at the whole thing, it looks as though this area was entirely burned. Next slide. But if we focus on the high severity, you can see that actually within the fire boundary, a quarter of the area was skipped. Another about a fifth of the area was only burned at low severity. So this means that there's a variety of structure left on the land at various scales. Next slide. These legacies and the landscape diversity support a whole suite of specialized species. And here I'm focusing on wildfire adapted organisms. So everything from cones that open only when there's heat, or plants that have seed banks that wait for decades until a fire before they come up. On the bottom left is Corydalis, which I had never seen on land I'd walked on daily for 30 years. Morels and other ascomycetes, fruit in abundance after a fire. Really, really cool. There's beetles that have little heat sensors so that they know when there's a fire, and they all congregate to mate. There's woodpeckers that specialize in food from dead trees. And there's a whole bunch of birds that use snags to perch. And even goshawks. And we think of goshawks as needing mature and old forest, and they do. But they also use young primary forest. And I want to tell you, pause and tell you a little story here. Jim Pojar, one of BC's preeminent ecologists, took a bunch of us on a tour to the eco reserve in the Swiss fire a number of years ago, probably 20 years after the fire. And to get to the eco reserve, we had to walk through the area that was salvaged. And as we walked through the salvage, we were going through a uniform pine plantation. It was green, but we couldn't hear anything. We were just seeing pine. There was no variability, and it was ecologically boring. We reached the eco reserve, and the first thing we noticed is, okay, it's patchy. There's open patches, there's sun, there's butterflies in the sun. We noticed that there's snags still standing decades after the fire. There's logs where they've fallen. As we walked, we heard birds. Then we flushed the snowshoe hare. We sat down on a log for lunch. And as we sat in this patch of sun, amidst this young natural forest, a goshawk flew and perched on the snag right above our head. Now, okay, I know that as a scientist, this is n=1. It's an anecdote, but I must say that for me, that was a more powerful expression of the difference between salvaged and unsalvaged young forest than I've seen in any graphs. So I did want to share that with you. Next slide, please. So it's evident that disturbance supports specialized species. And also, if we look at pooling all species together, natural disturbance, it also supports general biodiversity. So if we look at indicators like diversity, species richness, habitat quality, then generally there's most often neutral or positive impacts of disturbance. So I think we can conclude that disturbance does not reduce ecological value. Next slide. So now let's ask, does salvage support biodiversity? Well, let's look at the salvaged stand here. The legacies are gone. We've simplified ecosystems, we've homogenized landscapes. It damages regenerating plants like the willows in the picture on the top right, which were growing, that's only 2 months after a fire. Facilitates invasive species, removes refugia. There's all sorts of cumulative impacts that I don't have time to get into, but things like changes to hydrology also impact biodiversity. Next slide, please. And so the studies that have looked at specialized species and asked, does salvage support biodiversity? It turns out that this is a meta-analysis over all sorts of ecosystems. In 8 of the 24 groups that they studied, it decreased species richness, the number of species, and it particularly impacts the species that rely on dead wood, as you would expect. And that's what this graph shows. So the different colored dots are different types of disturbance. We've got insect, fire, and wind disturbance. And we're looking at general species and species that depend on dead wood, so pairs of dots in each case. And what you can see is that the species that depend on dead wood in the fire and wind disturbance, so the red and the blue dots, are far below the line. And what this means is that the species richness has decreased for those organisms in these salvaged areas. Next slide, please. So we want to ask, oh, sorry, that one didn't pop up quickly enough for me to notice what it was. The other problem is that we see that it's really that natural young forests are critical for biodiversity, but these stands are rare over the landscape. And that's a bit of a puzzle. It's like there's all these fires and there's mountain pine beetle. We think that these should be everywhere, but you know what? They get logged so fast that they're actually fairly rare. So less than 10% of most ecosystems are actually in natural young forest. The graph on the right is some work we did as part of the Dominica ESI demonstration project. This is a collaborative project between Carriacou County First Nations and the province. And this is looking at the southern portion of the Dominica region. And what you can see on this graph is the percent of young forest in a number of different ecosystems. Each bar is a different ecosystem. The colored bits at the bottom are natural young. So the red ones are initiated by fire. The orange bars above are initiated by beetle. And then the dotted ones above are initiated by logging. Now have a look at the green line that goes across at about 12%. That's the amount that we would expect to be in natural young forest. And for most of these ecosystems, you'll see that there's less than that, 5% in some, down to 1% in others. So we have amounts of natural young forest that's far below what we expect, which puts biodiversity at high risk. Now, conversely, the young harvested forest is well overrepresented. These are those simplified stands, like the ones that I walked through at the Swiss fire, biological deserts. Some of them are salvaged, some of them are green harvested, but they're all young. Next slide, please. So let's ask, does it support biodiversity? No. Next slide, please. So let's look at carbon. So the perception here, and again, this comes from the province's recent release. They say salvage allows for quicker reforestation, implying that what we need to do is reforest. And this feeds into the myth that planting is going to actually fix our climate crisis. It's not for a whole bunch of reasons, but I'm not going to get into that right now. Next slide, please. What we can say is that these disturbed forests continue to store carbon in live and dead trees. Just because it's dead doesn't mean it's not storing carbon. And the graph you see here is also from BC. And this is looking at dead and live standing trees in fires of different ages. And you can see that the 0 to 10-year bar has a lot of standing dead trees. And then a lot of the small ones fall. And as we get in older fires, there are fewer, but the bigger ones are still there. By 50 years, we've still got standing carbon storage. And burn snags decay very slowly. It's a way that we preserve wood. So we do not need to remove them. Next slide, please. And it turns out that actually there's no need to plant. We don't need to reforest because there's some work Alana Klassen and her colleagues did in BC. What they found is that in subboreal spruce forests, the unplanted stands regenerated just as well as the planted stands. So what you're seeing on the graph here, the red bars on the left are not planted, and you're looking at the density of seedlings, and the blue ones are planted. And each bar is a different decade of age of the fire. So 0 to 10, 10 to 20, up to 50 to 60. And you can see they're the same. Now, it turned out that by 60 years, the planted stands had slightly more live carbon, but next slide, please. This increase was not enough to compensate for the losses from the dead wood that was removed for planting. So in order to plant, well, they salvaged for economic reasons, and they took down trees for safety reasons. And so if you look at the two panels, you'll see the live carbon increased, but by less than the loss of the dead carbon. And the title of the paper says it all. 5 to 60 years after fire, planting trees does not compensate for losses in dead wood stores. There is no reason to plant. Hence, there is no reason for carbon to harvest. And the important thing here is remember that planted trees are not going to remove carbon in the time we need. We need to be keeping all the carbon we can by 2050 if we want to avoid the worst catastrophic effects. Next slide, please. So, does post-disturbance harvest store carbon? No. Next slide, please. How about adaptation? So there's a perception that salvage will decrease future disturbances. And there's a lot of talk right now with a focus on wildfire. Because yes, we are worried about the severe fires in our area. So let's look at what we can find there. Next slide, please. We don't have great data from BC here, so I'm showing you a couple of studies from a well-studied fire in Oregon. And what you can see in the top panel, look at the black bars. The panel on the left looks at fine fuels. The one on the right looks at coarse fuels. And if you look at the two black bars, the low one is the area that was burned. Not that many fine fuels, not that many coarse. And the high one is the area that was burned and salvaged. So salvage increased the fine and coarse fuels, which we would think might increase the rate of fire ignition, perhaps even fire severity, though that's a little harder to figure out. Another study found out, oh yeah, actually, the salvaged stands burned more severely in the next fire. And that's what the bottom panel shows. Each of those 4 columns is a different ecosystem, and they're different from ecosystems in BC, but you can still see that each pair, so the lower dot is the unsalvaged and the higher dot is salvaged and planted. And in each case, the salvaged and planted had it burned at a higher severity than the unsalvaged. Now there's variation by ecosystem, and there are ecosystems where salvage has decreased the severity of future fires, but most of these are in California, so even less applicable to BC. Next slide, please. But we need to kind of put this all together and look at all different ecosystems. I mean, ideally, we'd have stuff from BC, and I know Phil's been doing some of that, but we're not quite there yet. So there's a recent meta-analysis that looked at a bunch of different types of disturbance and asked if salvage logging mitigates future disturbances. Does it help? And the answer is it's complicated, but I'm just going to read their conclusion. Salvage logging does not necessarily prevent subsequent disturbances and may increase the likelihood and magnitude of some. And in relation to wildfire, it rarely appears justified as a way to reduce fire likelihood. So this does not seem like a really resounding endorsement of salvage as helping us with the future disturbance. Next slide, please. We know that burned forests resist wildfire. We know that in many ecosystems, burned forests resist wildfire for at least 20 years, sometimes more, because they've burned the fines. And there's a meta-analysis in the Western US that found that burned forests, if they're in the interior mixed conifers, which are the most similar to BC, that it's as effective as thinning and burning for reducing future fires, where thinning and burning is the kind of gold standard if something such exists of fuel reduction. And I won't go there, I'm focusing on salvage, but it is as effective. Okay, if we can go to the next slide, please. And so now we'll put these all together. Does post-disturbance harvest support biodiversity? No. Does it store carbon? No. Does it adapt to climate heating? Mostly no. We'd really like a bit more evidence in BC. So why salvage? Economics. That's the reason. It can bring in money. And there are communities struggling. There are nations struggling. There's forest-dependent communities. There are people struggling in rural BC for a whole host of reasons, most of which stem back to colonialism and the machine that followed that. And it's because right now we're reaching the fall down in timber supply. We are running out of timber. And it's really important to know that this was planned 50 years ago or more. They knew this would happen, but the people back then didn't want to reduce their cut then because they thought, you know, they didn't want to help an uncertain future time. They were not thinking generations ahead. Well, now we're in that uncertain future time, and guess what? It's certain we've run out of timber. So that's what's happened, and that doesn't help communities, though. So I think, you know, salvage, let's just be clear. We're harvesting it for economics. There's no ecological reason to salvage. Next slide, please. More and more people are thinking, how about let's restore by leaving alone? Nature does this super well. Doing something isn't necessarily better than doing nothing. This is a global meta-analysis that found that active restoration didn't lead to faster or more complete recovery, and concluded that if we let ecosystems repair themselves, in many cases, this may be the best strategy. Next slide, please. So I suggest let's think of disturbance as an opportunity to change direction, to move towards that paradigm shift that Seraphine was talking about. So let's think, what if a crisis reaches your community? How do you plan after a fire? How do we do that if we think of wildfires restoration? How do we think of it as a new beginning? Next slide, please. And so here I'll share about a collaborative restoration plan. We worked with Natalie Stalatin and Silkes Co. in the Shovel Lake Fire Restoration Plan that burned portions of their territory. Through a bunch of meetings and workshops, community members identified their priority values, and together we worked to map restoration zones based on those values and to design treatment options that would have the best chance of maintaining them within the fire area. Next slide. So rather than the old paradigm of timber first, and then think of everything else secondarily, next slide, the community came up with a long list of values and services of which timber was one. Next slide. So together we mapped restoration zones. And that's what you can see in this picture here. The bottom in yellow is the wildland urban interface around communities where we need special management. And the red lines are the fire guards that were cleared to fight the fire. And then there's the big green one, which is the special restoration zone. And this is where things will be done differently. And this was based on primary forest, so mature and old, as well as forest that was young, natural, before the fire. It also includes moose habitat. It also includes riparian. It includes important cultural areas. It includes corridors, connectivity, and other values, all put into this special zone. And so once all those values have been dealt with, the rest was left as timber restoration. Next slide. And if we look at the area in each zone, what you can see is that the right half of the pie, which is half of it, is in zones that are not timber restoration. So we're actually, just by fluke, the communities came up with a plan that achieves the 50 by 50. The green lines at the top are already designated zones. The blue and the cream came from this process. Next slide, please. So some of the treatment possibilities, well, around communities, obviously safety matters most. This is where we need to manage fuel with opportunity for firewood cutting, as long as there's large trees left for fuel breaks, planting of deciduous and culturally important shrubs, and not planting dense conifers. Next slide. In the fire guards, this is where we can plant for carbon to help restore these areas that were cleared. Next slide, please. And in the special restoration zone, now this one shows the green divided up into different types of restoration zone. So some of them are ungulates, some of them are connectivity, all sorts of different reasons there. If we can go to the next slide, please. We have a variety of different treatments. But the overarching idea is to let nature restore herself. She knows how to do it. And that we avoid or limit post-disturbance harvesting. And particularly, we keep large dead trees, live trees, deciduous. Maybe in some places there could be some partial post-disturbance harvest in order to create small-scale gaps in the severe burned areas. And also avoid standard planting, maybe consider alternative planting patterns, diversity of species. This is where we could do some things differently, and they're currently looking at that. And there's a whole bunch of specific strategies for focal species and riparian areas that I won't get into today. Next slide, please. The community came up with a whole bunch of treatment options in the important cultural areas, and I know that they're starting to implement some of these. Next slide, please. So then that leaves the gray, which is the timber restoration zone. And this is where, I'm not going to say status quo management, because we hope it's not status quo management, but this is where there may be opportunities to do practices that people have in the past. Next slide. So in the timber restoration zone, there is potential for salvage harvest, particularly in the severe burns. As long as the salvage is designed to maintain midterm timber supply, so leave live trees, and allow natural regeneration in the stands that were burned at low severity, because there's already trees there. And this is an opportunity to plant for resilience. So to plant a portfolio of species like the colored bar, the colored graph at the bottom, which shows the mix of species that's optimum for this burn area. So we can plant those to adapt to climate change. And plant severely burned slopes, except the ones that might convert to grassland. Maybe try putting some Doug firs there. Well spaced, we'll see what happens there. Modify a stocking and leave a lot to regenerate naturally. Next slide, please. So this is my last slide. So I wanted to ask, well, should we salvage harvest in an era of crises? And I think that the Western science says, well, it matches what Seraphine's Indigenous science is telling us. No, this is not salvation. In fact, I think if we keep on with the status quo, it's just damning us to create further trauma, further separation from the land, further errors. So let's not make things worse. At the same time, we need to recognize that some communities have timber as one of their values. And I think in those cases, post-disturbance harvest can be part of the mix. But let's call it what it is. It's not salvage. It's post-disturbance logging. And let's do it better. And I believe that the next talk that Phil is going to share some ways of doing things better. Thanks for the opportunity, and I look forward to hearing the rest of the talks.
Thank you so much, Karen, Dr. Karen Price. Next, we'll hear from Dr. Phil Burton, and he's our third speaker before the 5-minute break. So Phil, I'll let you have the screen.
Thank you, Michelle. Thank you, Karen. Okay, greetings from Terrace, BC, Tsimshian country, traditional territories of the Kitsilus and Kitsim-Kalim First Nations. You'll pardon my play on words here. I'm trying to salvage some of the ecological integrity from post-disturbance logging, from the machine that we've been hearing about, and from the economic priorities that continue to drive our management regime in BC and elsewhere. So start off with some definitions, just so we're all on the same page. Of course, we're always talking about harvesting of dead or damaged trees. Sometimes this overlaps a little bit with sanitation logging, which some people call preventative salvage, getting those susceptible trees to market before they actually are killed by insects, disease, or wind or fire. In this talk, I'll repeat some of the things that Karen said in terms of impacts and implications of post-disturbance logging. Then I'll invite you to take a landscape perspective to provide some guidance on where, when, and how we might safely do some post-disturbance logging. Then focus down, drill down into some site level guidelines, and end with some regulatory concerns, I think, that are restricting our ability to do the right thing. So as mentioned by the previous speakers, we're in a biodiversity and climate crisis, which in many ways is expressed in natural disturbances on the rise throughout the world, whether those are wildfires, insect outbreaks in the form of bark beetles or defoliators, and increasingly invasive insects from other continents, and storm damage, whether that's tornadoes, downbursts, or in some places like the eastern seaboard and around the Gulf of Mexico, hurricane damage. And all of those things leave large areas of dead and damaged trees, a heavily modified forest ecosystem. And as Karen listed, there's many different species that actually are evolved with and attuned to that habitat. Various birds and insects, especially the longhorn beetles, a number of vascular plants, a number of fungi species, including the morels that we so often like to forage for in burnt areas. And we're only beginning to learn about the microbial associates, the populations that increase in response to different kinds of disturbance, Often ignored, however, are some of the hydrological and carbon storage roles of naturally disturbed forests. Here are some fisheye photos taken from a number of research projects I and my students were involved with. And even after mountain pine beetle outbreak, we see we still have 80% canopy closure in trees that had been killed by mountain pine beetle 3 to 5 years earlier. Or in a burned forest, we still have 64% canopy closure. So that means that we have only 20 to 36% equivalent clear-cut area, or ECA, which is a measure of hydrological vulnerability. So this is not bare ground with snow and rain hitting unprotected soil. A lot of snow will get intercepted by branches, some of it evaporate away. There is roots and again, rainfall impact protection from that helps prevent erosion. And so these burned and insect-eaten stands still serve a role in moderating heavy precipitation events and moderating stream flows. Also carbon. again, Karen explored this somewhat. Here's some research by a former master student of mine who looked at 5 wildfires between Pemberton and Boston Bar in the southwestern portion of BC. And he compared the above ground carbon stocks of unburned stands, the green symbols on the far left, and their range of natural variability indicated by the green shaded area, with those in moderately and highly burned portions of the wildfires. And about 40% of those burned stands had just as much carbon as the unburned area, and somewhat in proportion to the burn severity as measured on the horizontal axis by the relativized burn ratio as determined by satellite. And we're not even talking about differences in decay rates of case-hardened burned snags, of charred wood and black carbon or charcoal that resides for long periods of time in the soil. So here's where we run up against the socioeconomic reality, the socioeconomic scan, as Michelle likes to call it, and that is its impact on timber supply and the machine of the forest management response. And again, just to reemphasize what Karen concluded with, the reason we salvage log is for its economic value. For much of society, many of our neighbors, most of the corporations, most agencies of government, the forest is timber. The timber is a resource. Its value to humans is in generating dollars and in generating jobs. So when faced with a damage to that resource base, as indicated by the graphs on the left from the 2021 fires in southern BC, large portions of that resource, 5 to 20% in some cases, has been compromised by the destructive effects of fires, or in some cases by insect outbreaks. The knee-jerk response is to do what we do best, which is get out there and grab it all. Clear-cut logging, that's the business as usual practice, which often resulted in large areas of denuded landscape. During the pine beetle salvage days, we sometimes had 500 hectare clear cuts. If you combine them with all those that had been logged before, some of them reached up to 10,000 hectares in area of forests under 20 or 30 years of age. And that goes off to the mills, whether it's a sawmill, a pulp mill, or increasingly to the pellet fuel industry. And that's another whole story of the demand, the artificial demand created for pellet fuels that in the name of biofuels will take everything we can throw at them. So to reissue the question, can nature or ecological values ever benefit from salvage logging? So rather than the absolute no that Karen posed, I would say rarely, very rarely, but with a number of caveats, depending on landscape context and if there is a redirection of existing logging. So first of all, what do I mean by landscape? Well, it could mean this valley, the catchment area that drains into a single third or fourth order creek. We're typically talking thousands of hectares. It could be a Keyoh, as described by our first speaker. It should be a landscape unit. It could be at least, it should be the sustainability unit over which timber supply is supposedly calculated. Timber supply area or a tree farm license, perhaps a woodlot. So here's what we have to ask ourselves. If old growth is rare in this landscape, but there is abundant young natural forest, so as in this diagram here, old is anything over the minimum harvest age of, what would that be, 91, 92 years. And there's very little natural forest. Then salvage logging, if there's abundant young natural forest, as indicated by the bunch in the 20 to 30 year age class there, then salvage logging could delay further liquidation of the old forest if existing logging commitments were shifted to that naturally disturbed forest. In contrast, if old growth is abundant and young naturally disturbed forest is relatively rare, then do not salvage log. Those naturally disturbed forests are a limiting habitat in those sorts of landscapes. Okay, so this is an example from my colleagues in Boreal, Quebec, and we can think of analogies here in different timber supply areas in British Columbia. Ideally, this would be done, like I say, at a landscape unit or a Keyoh sort of scale, or a trap line in some parts, like in the Peace River country. A lot of the traditional territories are aligned along trap lines. Similarly, we could recognize the house group designations of Gitxsan and many other First Nations as being natural or long-lived or legitimate sustainability units, landscapes over which multiple values have to be maintained. Whatever you do, do not elevate harvest levels above sustainable levels. And that's what happened during the pine beetle outbreak in BC. Here's an example from the Colonial timber supply area, where the allowable cut was increased so that essentially 50 years worth of wood was harvested in 15 years. Well, those pigeons have now come home to roost. And once there was a downtick in the lumber market, mill closures started happening all over and are continuing to this very year. And that was predicted. Again, as Karen pointed out, this was known at the time of these decisions, not just in terms of salvage response, but in terms of the overall program, the policy of converting all available primary forest, all available old standing forest into short rotation managed plantations. Another landscape perspective is to do what I would call a values check. What do the citizens or the agreed upon land use plans and resource emphasis zoning say should be the priority? So obviously in parks and protected areas, old growth management areas, there should not be any salvage logging. We're saying those areas should allow natural processes to prevail. And if old growth management areas, OGMAs, are disturbed, they should be allowed to stand and go through their natural cycle of rejuvenation, but they may need to have replacement OGMAs designated to also provide for those old forest values. Special management zones usually would also be exempt from salvage logging, but it would depend on which particular resource or value is the priority there. Certainly not in community watersheds, high biodiversity emphasis zones. This big gray area, much like in Karen's map of the restoration plan for the Shovel Lake fire, is the multiple use integrated resource management zone, where the options really have to be balanced. Salvage logging could proceed based on some of those considerations I raised earlier, like forest age class distribution. We should be targeting the dead timber only to jump ahead to the site level guidance here. But let's not forget that some land use plans, some at the broad regional level, like the core plans, some at the landscape unit level, also have, in many cases, timber emphasis lands or timber production lands. And sometimes those are privately held by industry or corporations. And here I think we have to recognize that salvage logging would be expected for investors to recover their losses as quickly as possible and to replant them. But still, we would expect them to have protection for normal environmental values like riparian soils and wildlife. Down to site level considerations. Well, here we have to think about the different kinds of disturbances and their severity. It's useful to recognize that insect outbreaks and windstorms kill trees from the top down, leaving lots of green trees in the understory, those that were unsusceptible species. So the forest is not dead and it already has a head start on recovering. Fire, on the other hand, kills trees from the bottom up. So you don't have those understory seedlings and saplings, and tree regeneration will depend on seeds or surviving cones that have to disperse in from outside the fire. So what does this mean for salvage? Well, in terms of insect outbreaks, we have some experience in understanding where and when we can anticipate secondary structure or sufficient advanced regeneration to have full stocking, even if the overstory, even if all the even-aged pine trees that are mature are dead, and which areas are already fully stocked. So based on this spatial modeling done by my former master's student, Darren Brooks, we can recognize areas that have low or no understory stocking in red and orange. It's just a carpet of feather moss, and it would take 10 or 20 years for that feather moss to decompose enough and for seeds to germinate and punch through it to start regenerating the forest. In contrast to the green areas that have lots of spruce and fir in the understory and are already well underway to forming a new forest. The priority then would be to salvage log those areas that would benefit most and soonest from artificial regeneration. And this is just assuming that timber is our value, is our priority. Let's apply the same principles to fire. This is a burn severity map, again, based on satellite imagery, analogous to the one Karen showed you for the Shovel Lake fire. This is another one from the same year, the Nadina Lake fire. And we can recognize both visually and by their greenness signature that the satellite picks up, a gradient, but often mapped in 4 main categories of burn severity. The unburned stands basically are patches within their fire skips we would leave. These are critical islands of healthy forest. They are lifeboats for the recovery of the ecosystem in a disturbed landscape. The low burn severity ones are, based on what the satellite sees, still mostly green. Okay, those should be left as well. In contrast, the ones that are high severity, they're the most blackened, and we might say, well, that forest needs help to recover, doesn't it? We should log it and replant it. But in many cases, that reflects heavy charring, and those areas are undesirable by the industry because of that charcoal that's not wanted in lumber, pulp, or pellets. So the target often for salvage logging is the medium burn severity areas, those trees that were killed by the fire, but are basically intact, that hasn't necessarily actually burned up the bowl of the wood. It's killed the tree, but it has not burnt or consumed the wood. Now, as a simple rule, applied at whatever scale, is simply to not cut the living green trees. And there are some contractors who specialize in this sort of form of selective salvage. David Jorgensen there from Prince George with smaller machines, more careful logging. And we've done some research comparing selectively logged beetle kill stand with clear-cut logged stands. And partial cutting has been found to reduce or even avoid any net carbon losses to the atmosphere based on eddy flux towers that take that carbon balance footprint over an area of about 40 hectares. In the net difference over the whole growing season, in that case, was no net loss of carbon in the partially cut stands. If clear-cut logging is used, it's been recommended that one implement a conservation uplift for reserves and wildlife habitat patches. This was in chief forester recommendations during the pine beetle outbreak, and then most recently during wildfires, whereby we should count on doubling or tripling normal in-stand retention targets. depending on how large the contiguous area of recently logged forest is. So if our normal guideline based on biodiversity emphasis would have been to have 10% retention, that should be up to 20%, where we're planning on, we're accepting that we're going to retain standing dead trees, not just green trees, or even 30% if it's in large openings or heavily logged landscapes. Another thing about salvage logging is that it's best done in a year or two after the natural disturbance. And that's for a couple of reasons. One, so that the wood doesn't deteriorate, you retain that economic value. But secondly, from an ecological perspective, so that you don't damage the natural regeneration that has started. In many ways, you try and fool the ecosystem. That is just one blow, not two blows that are happening in short succession. On the other hand, to access timber, you typically need really careful road layout, construction, and water management to avoid all sorts of sedimentation and environmental degradation. And it takes time for new roads to set up. So a simple adage here is simply to restrict salvage operations to existing access roads. Don't go out there and start building roads to access damaged timber in the desire to get to it quickly. And finally, some regulatory and administrative concerns. In the past, one could get a community salvage license or permit, cutting permit, with as little as 15% trees dead or damaged. I think that's been increased to a 40% threshold under the April changes to the BC Interior Appraisal Manual. But that still means that people can go out there and mostly harvest green trees under the auspices of salvaging timber. And often that timber is paid to the public purse at a discount rate of only 25 cents a cubic meter, even if much of it is sold as solid saw logs. I'm also concerned about optimistic estimates of recoverable losses, which is the term used in timber supply reviews for the salvage of natural disturbances, which I think partly leads to elevated allowable annual cut determinations. And as I implied before, we have perverse international incentives supporting biofuels and the pellet industry, meaning that salvage logging often proceeds even where it would otherwise not be cost effective. Finally, I also hear mixed signals as to whether WorkSafe BC requires dead trees to be felled before planting. And if we are to achieve the nationwide goal of planting 2 billion trees, burned areas is one of the priority areas for replanting. So I'm not sure if and how danger tree assessment based on burn severity and sample surveys or walkthroughs can be done, but it seems, again, very counterproductive to knock down all that carbon in order to start new little one-year-old seedlings starting to put on carbon again. So a bit of a summary here. First and foremost, let's remember that most of our northern and western forests are very resilient. They do not need our help to recover. Salvage logging can constitute a double hit to their natural cycles and ecosystem processes. Naturally disturbed forests fill important biodiversity, hydrological, forest regeneration, and carbon storage roles. Nonetheless, the reality is dead trees will be logged for their economic value and the employment that provides. How can we minimize that damage? Well, if we can reduce pressure on logging green old forest, if the age classes agree, it might be worth considering, but do not increase overall logging rate. No salvage logging in protected areas, high biodiversity areas, OGMA, special management areas. Let's accept that salvage logging is okay on production lands, whether we agree with that zonation of production or not. A more balanced approach in terms of age classes and habitat types is needed to guide salvage logging on integrated resource management lands or multi-purpose forests. But we can avoid logging stands that have abundant secondary secondary structure or advanced regeneration. We can avoid logging in low burn severity areas. We can harvest dead trees selectively. And we then should be elevating retention levels at stand and landscape levels. Let's use existing access only, and let's review some of those perverse incentives that seem to encourage salvage logging. And I would just end with the caveat that these are my own opinions and suggestions. They're not the recommendations of any institution or organization with which I'm affiliated. And I thank you for your time.
Thank you very much, Phil. So we're all going to take a very short 5-minute break, and we'll see you all after the bio break. Thank you, everyone. We'll see you in a few minutes.
Okay, we're back. I'm Kate Logan. I'm with Conservation North, and I just wanted to thank everyone very much for rejoining us. And again, a big thank you to our presenters so far. So I'm going to get straight into introducing the next guest speakers, but I just wanted to give a quick reminder that we will have a Q&A at the end of the webinar with all the presenters. So please just pop any questions that you have in the Q&A box at the bottom of your screen, and we'll do our best to answer all of them. Some of you have already been doing that, which is great. If you have a question for a particular speaker, it would be great if you could note their name when you submit their question or your question so that we can direct it properly for you. Okay, so without further ado, I'm delighted to introduce Drs. Diana Six and Dominick DellaSala. Dr. Diana Six is a professor of forest entomology and pathology at the University of Montana, a fellow of the Royal Entomological Society, and a recipient of the E.O. Wilson Award. Her research focuses on the ecology and evolution of bark beetles, including how bark beetle outbreaks influence forests and may help facilitate their adaptation to a changing climate. Much of her work happens here in North America, but she and her lab also work as far afield as Africa, Asia, Australia, and Mexico. We are delighted that she agreed to join us this evening, so thank you, Diana. Dr. Dominick DellaSala is Chief Scientist at Wild Heritage and a former president of the Society for Conservation Biology North America section. He's an internationally renowned author of over 300 peer-reviewed papers and 9 award-winning books. And we've also seen Dominick's work in National Geographic, Scientific American, Time Magazine, and the New York Times, among others. His work focuses on temperate and boreal rainforests and dry, fire-adapted forests. He's dedicated to bringing forest science to policymakers on both a national and global scale. And we're so pleased to have him with us this evening. So thank you, Dominick. Without going on anymore, I would like to welcome to the screen Dr. Diana Six.
Thank you, everybody, for being here. Today, I'm going to talk about what no one sees. And in fact, I shouldn't say that. It's just what few people see when they encounter a post-bark beetle outbreak. And I'm going to put that in the context of salvage logging, of course. So what I want to start with is what people actually see when they look at a post-bark beetle outbreak, and that is a big sea of dead trees. And this can be a really disturbing perspective for a lot of people. But what I want to talk about, though, is what people quite often do not see. So what do people typically not see when they look at an outbreak? And that is that not only are there a lot of big trees that have been killed by beetles, but there's also a lot of small trees. There's a lot of mid-sized trees that have escaped just because they're a little too small. A lot of these tree-killing bark beetles only really like to go after the big trees. And every once in a while, you'll see these great big trees that have survived the outbreak. And then if you come and you return to those forests after a number of years, you'll see that the forest is actually in pretty good shape. Just as Phil talked about, there's little trees coming in, the mid-sized trees are growing up, the big trees that have survived have remained. And so these forests are actually extremely resilient, and most of them recover just fine. You'll also see, of course, a lot of the dead wood starting to hit the ground. This is very protective. It helps regeneration and, of course, nutrient cycling. But even if people perceive this resilience in the forest and can see past the dead trees, there's some things that tend to be missed. And one of those is that these outbreaks may actually be facilitating adaptation to change. And that's what I'm going to talk about today. But before I jump into that, I'd like to talk about a couple of things about bark beetles that are really important. And one of those is that they are among the most important natural disturbance agents we have in conifer forests. They're also very highly selective. They don't just go into any tree. We have a lot of different species of beetles out there. They're all very specific. They only go into particular species, and they do only go into certain size classes, particularly big trees. They go into trees based on their chemistry. Trees put out a lot of different chemicals. That's why some of our conifers smell so good. The beetles use those to pick particular trees due to different metabolites, defensive chemistry, and also by tree quality, because they have to raise their kids there. Those trees have to have fairly high nutrition. And they also choose trees depending on their population status. And so if you have really low populations, these beetles have a very hard time mustering up enough help to be able to mass attack a tree. And so they go after the very, very weak trees that require very few beetles. But if you get something like a fairly warm drought or drier conditions like we're seeing, a lot of trees across an area get stressed, and then it's easier for the beetles to build up. And once they become high in numbers, many of them, like mountain pine beetle, then switch to going after healthier trees. Now, keep those in mind because they're pretty important to my story. But I do want to go into why natural disturbance, being a natural disturbance agent, is important. A natural disturbance, if you take an ecological definition, is an event that disrupts the ecosystem. Having that term natural in there implies that it's normal for that ecosystem, and it's something that that ecosystem has evolved with. We've learned over time that the removal or suppression of these natural disturbances can cause negative shifts in ecosystem function and stability. And I think a really good example is what's happened when we've tried to remove fire. Also, being selective is super important because if you're selective and you're a natural disturbance agent where you're killing trees, but you're only killing certain ones, that makes you a natural selection agent. So if you think back to your biology classes, way back when, you'll remember that natural selection is really the mechanism of adaptation. Organisms better suited to their environment are more likely to survive and pass on the genes that allowed them to survive. And of course, the process of those selective agents and removing those that are struggling allows a species to adapt to new conditions over time. Now, most people think evolution or adaptation is really slow. It takes millions of years. And that's true if we're talking about really, really big changes. But if we're talking about small stuff like adaptation to more droughty areas, warmer temperatures, we're talking about developing more resistance to beetles, the process can actually be quite fast, and even in forests. And so this idea that these big outbreaks of beetles, and beetles tend to go after struggling trees, may actually be a big natural selection agent helping our forests adapt to the future is something that my lab has been looking into. And so I'd like to share some of the work that we've been doing. And this sort of came about from me walking around in forests that look like this one, wondering why after the beetles had really built up and there were literally millions of them flying around, and they had eaten themselves out of house and home, that they weren't killing some of these trees. These trees were coming through virtually untouched. And so I, having a genetics background, didn't think this was by chance. I wanted to see if there was something different about these survivors. And so here is a very strange slide, I admit, about my experimental design, and it's more a prop just for me to remember how to explain it. But what we did was to go out and find these forests that had been very heavily affected by the bark beetles. And in those forests, we look for trees that have been killed by the beetles. That's your number or your letter B here. Those, of course, were super easy to find. Then we look for the survivors, which I've got an S here. And because we wanted to look at the genetic change that might be happening, and we also wanted to look at the chemistry, both genetically based traits, obviously, and we couldn't do that from the beetle kill trees. What we did is we also looked at this other group of trees, which we're calling general population, because we couldn't come up with anything better. But these were mature trees, big trees, but just a little too small for the beetles to attack. And so we use these as a proxy for what that population would be like before beetles ever showed up. And so let's say if we had a population where 5% of the trees survived and 95% were killed, we assume that about 5% of that population should share a genetic profile with the survivors, and about 95% should be something else, susceptible, if our hypothesis was right. So we went out and we got needles to extract DNA for the genetic profiles. We collected phloem to get the chemical profiles to see if any of these were informative. And we took tree cores to look to see how these trees, whether they were survivors, generals, or beetle killed, were responding to climate, how their growth rates may be different. Tree cores are pretty cool. When you take them out, it's like reading a tree's autobiography, because every single ring is a different year in that tree's life. And if the ring is nice and fat, it means that tree was living very good that year. And if it was really skinny, the tree was struggling. And we can line up particular years with each ring, and then we can look at precipitation or temperature data and see how that tree responded. And we could look for differences in growth rates and response to climate between these survivors and beetle-killed trees to see if there were differences. So I'm going to walk you through a few of our results. I'm going to focus on just two populations of white bark pine with mountain pine beetle. We've actually done a number of populations now with all the pretty much the same results with white bark and some lodgepole. But again, I'm just going to show two populations. These are results from the genetic profiles, and if you're not used to these, this may look a little intimidating, but it's actually pretty easy. Every point is a different tree, and the program clusters those together that are most similar, and those that are the furthest apart are the most different. And then the different colors are the different categories of trees. And so up here, we have the red and the green. This is one site in Idaho. This is Poverty Flat. We have the survivors and we have the generals. And again, what we predicted is that they would be different, but that in the generals, there'd be a little bit of overlap of a few trees with survivor genotypes. And what we see is, yeah, the green ones, the generals, are very different from the survivors. And we have this little bit of area of overlap. For the other site, Bipond Park, that's in Montana, again, the blue is survivors, the yellow, which I'm hoping you can see, is the generals. Oops, going ahead of myself. And again, we have two differences. These are statistically different, but we have overlap. It's just bigger than before. But again, we have support that something is genetically different. And to me, that's encouraging because that's heritable. It can be passed on to the new forest. This is analysis of our chemicals that we looked at, the tree chemistry. Again, it looks kind of weird, but it's actually easy to read. What we have over here are all the different chemicals that we looked at, and each row is a different chemical. Where you see the dark color, that chemical is very highly concentrated. There's a lot of it there. If it's very light, there's either very little or none. And the vertical lines are individual trees. The colors correspond to the two different populations. We have over here Vipond Park in Montana. This is Poverty Flat in the green. And again, this analysis groups trees together that are most similar, and then the further apart they are or in a different cluster, like you see up here, then they're more different. So if we look at this population, we can see there's this one very different group. And let me explain how to look at the colors. The darker colors, the dark maroon and the middle maroon, are the survivors. It's just differences in ages. And then the light pink are those generals, those smaller trees. And you can see that over here we have this one cluster, which is all the big old survivors. And in these two clusters, they're different, but there's a real mix of generals and survivors. So no clear pattern, really. When we come over here to the Idaho site, oh, I've got to quit doing that. Over here at the Idaho site, we have a better differentiation. We have almost all the survivors, the dark colors, in one cluster, and over here it's almost all the generals. But the problem is we don't see any real correspondence in any one chemical or group of chemicals that accounts for survivorship. And as we look at more populations, they're all very different from one another. And so we don't think these chemicals are a cue that these beetles are using. So this brings me to growth rate and response to climate. And I'm just showing you one population here, but for whitebark pine, they all look pretty much like this. For lodgepole pine, many of them do. And I'll talk a little bit about those that don't in a second. But what you're seeing here is this blue line for this one population. This is the Montana population. Down here, the blue line are the trees that escaped beetle predation, that were avoided. And then this orange line are those that were killed by the beetles. And so what we find is a significant difference in growth rate. The trees that the beetles are not attacking are the slow-growing trees. The trees that are faster growing over their lifespans are the ones the beetles are going after. And that was true across all of our populations for whitebark and for most of our lodgepole pine. And that's now been found in some other studies that people have done. The beetles are avoiding the slow-growing trees. We don't know why. We think maybe it has to do with their tolerance for drought. Slow-growing trees have less demand for water. So maybe these trees aren't struggling, the others are, and they're more susceptible. We did some analysis with climate variables, and indeed these trees that are slower growing are fairly insensitive to drought. They don't change as rapidly in response to drought as the fast-growing trees. So this was actually our strongest predictor for which trees are going to survive, but it's going to take some more work to figure out what's happening. But we do know that growth rate is genetically based, and so this may be an adaptive trait. Now, this is all kind of cool data to, ecology people like me. But what about managers and the public? Is this important for people to know about or be aware of or seeing it? Is there a problem for people not to actually realize that adaptation could be occurring in our forests? I think there is, and I think it's important because for the manager, if they don't see this, it supports continuing a one-size-fits-all approach that's been applied literally for decades that focuses most on promoting fast tree growth and stopping or reducing natural disturbance, which are the very agents we need to speed up adaptation. For the public, I think it limits the ability to promote appropriate policy that can help forests adapt. And let me take that a step further by tying this into salvage logging. Because adaptation really is our long-term solution for natural forests, getting them to persist, I think that's important because there's so much where people feel like we have to give up, plant other trees, change the forest, assisted migration. To me, the best thing would be to keep the ecosystem and to try and help save what we've got. In order to do that, I think, and I like Phil's bit on this, we need to leave the green. If we want to pass on the genetic-based traits that these survivors have that might promote persistence under new conditions, then we need to leave those survivors behind. And unfortunately, at least in my area, usually the green gets cut with the gray because they bring in more money, it's easy, and it helps pay for the cut. But those are the trees we need most. Leave the gray, this protection for the soils, helps give seedlings and saplings from survivors a better chance to survive. And leave the small. There's a big push right now to go out and do heavy-handed fuels management. And this usually is to remove the vast majority of the understory, including the young trees that are coming up. Those young trees are our future forests. And if they are coming from survivors, that gives them a better shot. But also, those little seedlings coming up have to go through a very important second natural selection filter, which is to survive new conditions, to be able to get that taproot down fast enough to be able to survive under often drier conditions. So we need lots of those seedlings out there for selection to act, because a lot of them won't make it. We need to avoid clear cuts because they wipe out resilience and adaptation. And replanting is not a good idea either, because typically we're putting in seeds from stock that we've chosen. They haven't been through selection filters. And so we may be slowing down adaptation in that case as well. With that, some conclusions. Adaptation is how nature deals with change. It's been working fine for a long time. I think it works better than most, if not everything we do. And we can capitalize on this by using practices that aid and don't hinder this powerful process. And with that, I'll end. Thank you.
Okay, thank you so much for that, Diana. I know that there are already coming in and probably more, lots of questions for Dr. Six. So if you can pop those in the Q&A box, we'll get to them right at the end of the webinar. I would now like to welcome to the screen Dr. Dominick DellaSala.
Okay, going to be sharing my screen here, and thank everybody for hanging in here past the hours, and hopefully my power doesn't go off. My community burned down a couple of years ago, and they're hyper vigilant about cutting the power now whenever there's a fire risk, and I've been in and out of power outages all day today. So hopefully we get through this. Wonderful presentations today, and I'm really quite pleased to be part of these distinguished speakers and this event. And I hope that we do something after it as well to get this material out, because it's really insightful. I'm going to be agreeing with a lot of what I saw today by my fellow panelists, but I'm also going to take some different directions based on my experience with working on forest issues across the gradient of temperate and boreal rainforest to dry fire adapted forest, and seeing some similar patterns with my colleagues working in different places of the world, including Australia, where we're working on a paper currently looking at the biogeography patterns of what happens when forests burn and how logging disrupts those natural processes. Top of this, I don't know if it got cut off or not because it's hard to tell from, I got stuff on the top there. But anyway, the title is Out of the Frying Pan and into the Fire, or into the fire, out of the fire and into the frying pan, rather. I just get this out of the way. There we go. And this is what really is going on post-disturbance. It's not the disturbance itself that is the key factor, but it's what we do to the system following a natural disturbance that is a widespread form of forest degradation. We've got a couple of articles working on that with a global team of scientists seeing the same things that I'm reporting on to you here. And, you know, in any of this business, perspectives matter. And I'm going to be taking from a lot of the information in my new book that I did with Chad Hansen, hot off the press, just came out a couple of weeks ago. It's the second edition of Nature's Phoenix, which has 12 chapters that pertain to a lot of the biodiversity that we're finding in these severely burned forests. And it's mostly in the severely burned patches, not the light burned patches, not the mixed or moderate rather, but in the severe burned patches, we're seeing the highest biodiversity. And the perspectives matter because a lot of post-disturbance rhetoric calls it restoration, but it really is the most impactful logging to an ecosystem typically. And it's mostly about economics. Other panelists mentioned that money grows on trees, and this is a return on investment thing, and we should just call it that and not try to masquerade behind restoration or some other benign language, which it's not. And in the process of doing that, in many cases, environmental regulations are bypassed because the economic function for these dead and dying trees decays rapidly. And so they got to get to the logs as quickly as can, bypassing reviews on impacts. And, you know, really, it's like a cut and move on because of the time involved. There's all kinds of assumptions that the next fire or insect outbreak can be avoided by logging, but we really see it as being amplified by logging. I'm going to spend quite a bit of my presentation talking about circular succession. Everything is connected in these forests, and you can change the trajectories by working on any part of the successional circularity, and the logging breaks the ecological bank by intervening and sending it off on a different pathway that is degraded. And so my perspectives is based on lots of studies that me, my colleagues, and others have been doing on this issue for many years, documenting circular succession that has its highest value in severely burned patches. And the high severity patches within these patch mosaics are really where the action on a biodiversity standpoint is extraordinary and equivalent, at least in richness, but not in composition necessarily, with what you see in old forests. We just finished a paper that was published on the extraordinary high rates of logging in Quebec, where the Canadian government is calling it sustainable forestry. We've got a paper in review right now on the Ontario boreal that is showing the fires from last year were the result of extreme climate fire weather interacting with extreme logged landscapes. We've documented similar patterns in terms of losses in the interior wet belt and inland British Columbia rainforest that we've done with Michelle and others. And my colleagues are seeing some of the same things in Australia. So there's quite a bit of knowledge that's going into this in terms of the pattern recognition here. Okay, so I'm going to begin with definitions. And so as you can just kind of thumb through a dictionary and look up or do it online and find the definition of salvage, it really is a misnomer because it says something of value is being rescued, saved from destruction, or preserved of its useful parts from waste, discarded, or a failure. And really, this could be the farthest from the truth when it comes to the ecology of these places, as you will see in the corresponding slides. And really the degree of destruction and degradation from the logging depends on the intensity, type, and frequency of removals. But overall, it is just plain negative. And that's probably the most negative of any logging, except if you're doing clear cuts over large areas. You're really impacting the natural process and changing the trajectory that these forests otherwise would be on, plus other disturbances. So I want to correct the misnomer and just start by abandoning the term salvage. We shouldn't even be using this term. We should call it what it is. It's post-disturbance logging, because you're not salvaging something of at least ecological value by cutting it down. And what it really is it's logging and road building in many cases to quickly extract economic value following a natural disturbance. Usually a severe one is targeted, but not always. It's often mislabeled restoration, resilience, risk reduction, restarting succession, forest health, and on and on. However, it's mostly concentrated in high conservation value forest, and the degradation accumulates at scale, as you'll see in the examples. The targets include the biological legacies that others have talked about, altered trajectories. It raises fuels, and I'll show some examples of that. It kills natural regeneration. It damages soils and mycorrhizae, the processes. It depresses native species richness and abundance. And again, it depends on what you're doing, how much you're taking, and where, but it's pretty much across the scale that we're seeing this form of degradation that is most damaging to the natural processes. So when I started graduate school many years ago, we all learned this basic forest succession gradient, and it was taught to us as a linear gradient that went from the young pioneering stage that recently was disturbed by natural disturbance all the way out to the old growth, late successional stage in a linear fashion. But as I started to become more aware of what forests were, it actually is circular and interconnected. And there are many pathways that a forest can take and timelines when it had been naturally disturbed. And post-disturbance logging disrupts the circularity. It makes it linear and truncated. So you're really working on the left side of the linearity at the young age classes, and you don't really complete the cycle. And here's some perspectives that I learned. How I learned this is after I was done with my temperate rainforest book, I took a hike with my 8-year-old daughter to a severely burned forest pretty close to where I live. And we had our lunch in this severe burn patch after we came out of an old growth forest. And most of the biodiversity was in this severely burned patch. And so my 8-year-old saw it. She taught me about it. And I went on and I started looking at this closer. And what we have been discovering from working on this for about a decade now is the blackened forest actually recovered from the green forest if you're a blackback woodpecker and a lot of the other species that need blackened forest, and vice versa if it's a blackened forest that is recovered from old growth. Hence the circularity. It really depends on what species we're talking about, what ecosystems. The useful parts weren't damaged, they were created as legacies. And those legacies come in a variety of different keystone structures that are created by a pulse disturbance that then lifeboats the system for decades to centuries through circularity. It's very different from a chronic disturbance. I often tell folks when I go on hikes is that the time since fire matters. Don't just judge a burned forest by the initial event. Come back a year, 3 years, 5 years. And watch that natural process unfold. It is that complex early cirral stage before conifers close their canopies that's most biodiverse. And if all you look at the forest as being conifer-centric, you're going to miss that. So most of these sites have natural regeneration that is jump-started by the fire event. They don't need to be seeded, except in very low productive areas. And then even that has to be monitored and carefully planted so you're not overstocking and creating more fire hazards by dense stocking plantings. I love this slide. It's a beautiful picture of a complex early cereal forest with legacies in place, the understories coming back. The snag forest is as biodiverse as old growth. The dead in these forests are reborn. They have their second ecological life. And they are the most valuable components of these forests, in addition to the live trees, as we've heard from Diana's talk about the survivors having the genetic adaptation. So it's both. It's not either, it's both. This is a letter that we put together a few years ago in opposition to a huge post-fire logging project signed on by 250 scientists calling on decision makers to recognize the ecological value of complex early cereal forests that are the least protected of all forest habitat types because they're most often treated with post-fire logging. And so trying to get the recognition to these forests is really challenging because assumptions being made that it's the end and not the beginning. I put this up here because I like to contrast the disturbance effects from a severe natural disturbance versus a severe post-disturbance logging event. And you can see on the left, we have all beneficial factors involved with severe natural disturbances, especially when they're within a patch mosaic of varying patch severities. So you've got a beneficial pulse that jumpstarts circular succession compared to chronic degradation in a logging event. You create abundance in a natural disturbance. You remove abundance in a post-disturbance logging. And the legacies are prolific in naturally disturbed areas. They're degraded in areas that have been logged. There's impacts to soils. And interestingly, we've done some work in some of the really big fires in Northern California, where what we observed was a sink-to-sink lateral transfer of the carbon from live to dead pools and vegetation uptake. So 99% of the carbon in the live large trees was simply transferred to the large dead trees. It didn't go into the atmosphere. The duff and the understory was volatilized with some carbon release, but most of it remained in the forest. But logging is the reverse. You change a sink to a source of emissions with up to 80% of the carbon is emitted, depending on the severity of the logging and how the scale of the logging. So you just could see through all these different examples here that the landscape patterns are pyrodiverse in a natural disturbance. They're oversimplified in a logging disturbance. You have high integrity versus low integrity. The net effect is restoration and rejuvenation versus degradation. So I think this is really important because I hear a lot of assumptions about logging simulating natural disturbances, and it doesn't. What it does is it disrupts the circularity. So instead of having a mature forest going through its natural progression of circularity, you interrupt it and you put it into this degraded landscape and this degraded system that then shifts the whole dynamic in terms of disturbance dynamics and the biodiversity. You've oversimplified the system. You've gone from a pulse disturbance that can occur over long periods to a chronic disturbance that reoccurs. That's the shift that happens at the stand level and across large landscapes. Now, I know that others talked a little bit about hydrology, and the big problem with hydrology with this is logging on steep slopes and the mass wasting events that happen from that logging, the hydrological disruptions from the road system. These areas are heavily eroded typically, and that causes all kinds of problems with weed invasions, apex predator losses, unnatural fire ignitions, and those effects can extend out to 1 kilometer, more than 1 kilometer from the road prism, especially if you're looking at apex predators. So we've got to make sure that we also address the chronic road impacts when we're looking at post-disturbance logging. I think the Biscuit fire was already mentioned, and I think Karen had this up here, but I actually was on the ground doing plots after Donato did his famous study, and you can see on the left the initial logging in a reserve. This was an old forest reserve. As soon as the fire went through, all those protections were lifted, and that 10 years later, still no natural succession. Right up slope in an unlogged botanical area with the biological legacies and all of this natural regeneration. And we have plots, so this is not just an isolated photograph. Same thing with fuels. Now, the fuels transferred to the ground all at once instead of falling randomly. And I know in the case of the California study that was mentioned previously, the California logging removed the large fuels because those were the most economically valued, and that decreased large fuel inputs, but it increased fine fuels. And that's the stuff that's going to burn because that's the kindling in the fire, not the big logs. The big logs will give you simmer and burn duration, but the fine stuff will give you fire intensity and fire carry. And that's what kills firefighters. And I actually put this study together after I testified in the US Congress and hearing that protected areas were the problem. They burn most severely. We did the largest study ever on this, published a few years ago, and found that the protected areas actually were burning in lower severities than the logged areas. So if there's any concern about too much high severity, it's in these areas that have a heavy logging footprint. We're seeing some of the same thing now in the Quebec boreal study that I mentioned, that's in peer review, and in many of the Western North American dry forest studies that have been done. And my colleagues are seeing the same pattern in Australia. And when you combine this with climate change, that's when you're going to get these fires that are taking off. So I think context is really important, and I see a lot of proposals claiming only a small portion of the burn areas is going to be logged. I've given some examples here, and I'm just going to go through these quickly because I know we're running out of time. But here's 3 examples where the Forest Service proposed only small amounts of logging by taking the logging footprint, dividing it by the total burn perimeter. And when you look closely at it, it's concentrated mostly in the places of the highest ecological value: endangered species habitat, roadless areas, protected areas, wild and scenic watersheds, and other reserves. All of the logging concentrated in those areas that have the highest integrity. And so we took a look at this, and back when the Forest Service proposed 1 billion board feet from the Biscuit Fire area, which was enough to connect logging trucks from I-5, Interstate 5, from Canada all the way to Mexico. That was their proposal, mostly concentrated in protected areas. We took the protected areas out, we screened them out, said no-go zones, took all of those out, took the big trees out, and the agency summarily rejected our proposal. They went for the big logging bonanza on the left of the screen. Litigation happened. It slowed the projects down. By the time the agency got their projects through, they wound up with the same volume that we proposed, but with damages to those sensitive areas that we didn't want to go in there. So all I'm saying here is we've tried this with no-go and go zones, but really what's ruling these projects is economics. I'm gonna end with these next 2 slides here. One just relating it to the inland temperate rainforest and the interior wet belt. I am really concerned about that region. We published a paper a couple of years ago, and Michelle and colleagues were involved, and you can see the rate of loss of primary forest over periods of time in percentages. This is summarized from our paper. On the top is the wet belt, on the bottom is a subset of the interior, the inland temperate rainforest, going, gone. If those rates continue in primary forest, all of the primary forest will be fragmented in the rainforest within 10 years and the wet belt within 50 years. So if it burns and it was primary before, it's primary after it's burned. And there's no reason to put logging roads in it or take out the trees. You've got all kinds of ancillary problems with caribou. You really need to stay out of these areas. There's so little left, and post-disturbance logging just amplifies those impacts. Okay, so here's my concluding slide. Canada pledged to end forest degradation. but it's an empty promise. They are not fulfilling this promise, and neither is any other country that signed on to the Glasgow Forest Pledge to end deforestation and degradation by 2030. This is one of the most damaging forms of degradation that is occurring in the logging world. Nothing of ecological value is saved, rescued, or preserved. It's just a poor word choice to even use the word salvage. The complex early silver forests are the most biodiverse, the dead trees, the severe patches with the most legacies. And I agree with Karen's work there, Diana's work there about small trees because of the genetic adaptations. That's a bed hedging strategy because those adaptations will get them through the bottleneck. So you don't want to even overdo it on taking out the small trees. These impacts accumulate across scales, a range of taxa, and as we're finding across biogeographies, no-go zones just didn't work. They're lipstick on a pig. You still get expedited reviews, economics rule, and high conservation value forests are targeted. And again, in conclusion, some places are just too important to do any more logging, and those include primary forests, whether they burned, been eaten by bugs, or not. Sorry about the bugs analogy, Diana. We know that they're beetles. Keep logging to the existing footprint plus post-forestation to grow back legacies in older forests. And I just wanted to just comment briefly that severe fire does not destroy seed banks, especially in productive area. The seed bank is still there. Time since fire matters. There's a lot of heterogeneity, even in these big, high severely burned patches. We've documented this throughout Western United States with a huge burn severity patches have a lot of heterogeneity and a lot of regeneration going on. And if the regeneration isn't immediate, time since disturbance matters. One thing that we can do to restore those areas is close and obliterate the roads, do something about the culverts, and just stop degrading these ecosystems because it's amplifying the biodiversity and the climate crisis. Most of the carbon in those forests was stored, transferred from live to dead, and is emitted as a gross emission. And gross emissions are more important than net. When a climate emergency, we've got to keep the carbon out of the atmosphere. We don't have time for the net because of the carbon debt created by logging a primary forest. An old forest takes centuries to recover, and the gross is what we really should be looking at. And I guess the final point is Canada signed that pledge, but it's a broken promise at this point because degradation marches on, as we've documented now in Quebec, Ontario, and British Columbia, and we're continuing to do our mapping in forested areas in Canada and around the world, documenting how degradation avoidance is not happening. So I'm going to end there, and thank you so much for going extra time with us.
Okay, thank you for that, Dominic, very much. And again, a big thank you to all of our speakers tonight who were so generous with their time and their expertise. We'd love to ask them to stay a little bit longer if they can and answer some of the really excellent questions that have come in over the course of the evening. I will ask respectfully if they can keep their answers fairly succinct just for time. But I wanted to start with a question for Seraphine, which is, and I will read it so that I don't muck it up. It's a question from Martin, and he asks, sections 64 and 65 of the Forest Planning and Practices Regulations allow maximum cut block size and cut block adjacency rules to be ignored during salvage. How important is it to update these sections?
Okay, sorry, can you ask that question one more time? I might have missed that one in the chat.
Yep, I sure can. So sections 64 and 65 of the Forest Planning and Practices Regulations allow maximum cut block size and cut block adjacency rules to be ignored during salvage. How important is it to update these sections?
I think very important. I mean, I'm assuming other panelists are going to have a lot more to say. I'm not a forest ecologist, and by any regard, I mostly help on a high level and talk about social implications. not a quantitative analysis type person. So I'm going to pass that question to one of my colleagues here. I feel like you're going to have a lot more of a technical answer than I would in terms of recommendations for adjacency. And I'm also not a forester. I can play one on TV, but not in real life.
Okay, fair enough. Maybe I'll throw that one to Karen, unless anybody else has a burning desire to answer it. Karen, do you mind speaking to that one?
I think we need to be updating everything. I mean, we need to be shifting our whole paradigm. Which ones are more important than others? I'm not sure. I mean, you know, to me, the most important thing is that we've got to be cutting less. And there were a number of questions that were asking about trade-offs between green tree and salvage. And the point is that, you know, Dominick talked about the circular succession. All of these stages are at risk. Old growth is at risk. Young natural forest is at risk. It's not as though we can find areas where there's one that's not at risk and we can trade off. So, I mean, in terms of my recommendation of what is most important to change, that's the thing that's most important to change. But yes, I mean, we need to be doing everything differently. We need to not have any passes for salvage, because salvage is not better than green tree harvesting, and in many cases it's worse. So anything that lets us do that, we should take off the books, is my feeling.
Perfect. Thank you very much, Karen. Our next question is for Phil. This is a question from Ben. So since Ben asks, and I'll read it, since the 1980s and the huge upswing in logging on the Chilcotin Plateau in response to the mountain pine beetle, it seems that salvage logging approvals have always been in addition to what was already being logged. Are there examples where this has not been the case and companies have been forced to lower the rates of logging in natural forest while they are simultaneously salvage logging?
Yeah, thanks for the question, Ben. You probably are as familiar or more familiar with this history and examples than I am. I would say that at least during the most recent pine beetle outbreak, companies were encouraged to salvage log, but they weren't required to. And it's not at all clear that it came out of any existing cut, because the widespread nature of uplifts to the cut were on top of what was considered sustainable at the time. So no, I don't think there's any strong direction there or any requirements more than those sorts of chief forester guidelines.
Okay, thank you very much. Okay, so this is a question for Diana. It's kind of a two-part question. The first part is, can you elaborate on the problem of replanting and seed stock? And the second part is, do insect outbreaks increase fire risk?
Okay, those are long ones. I'll try to keep it short though. Quite often the seed stock that's used for replanting is not necessarily collected local. It's called that. It comes from seed zones. They aren't collected from surviving trees. So what you would get is a mix mash of seeds that could be from a different area, locally adapted somewhere else. Or if it's local, it may not come from survivors. And so a lot of the growth that might come up would be pre-selection, and you wouldn't have that quicker adaptation that selection would give. As far as the beetle kill creating more of a fire hazard, that's a really complex one, because forests that are affected by beetles are very complex and they're certainly not uniform. But in general, I would say no. There's a short period after the trees have been killed that they might be more flammable. But I'm not totally convinced, because just because a tree is green doesn't mean it's not flammable. If you've ever stuck a branch into a fire, they're not full of water. They're full of all sorts of terpenoids that are highly flammable. But once you've had beetle kill go through, that the needles drop, you have basically a fire break for canopies. And so you're going to have ground fires, which is what people want. You're not going to have these canopy fires because there's no canopy to carry it. So they essentially act as fire breaks. So the whole big hype that if we don't cut it out, we're going to have catastrophic fires is a little crazy. It's more fire weather than anything that's going to drive whether it happens there or not. At least that's a summary of something fairly complex.
Thank you. I really appreciate that. And I really appreciate all of you for your very succinct answers so far. This is another one for Seraphine. The question, Seraphine, is can you elaborate on the importance of language when it comes to traditional management in your Keyoh?
Yeah, again, I guess I'll try to keep that one succinct, but as I had mentioned, language is just a way that we see land. So an understanding of like since everything is very contextual, our language is unique and regionally specific. There's going to be certain things that you would say in Daketh that are just like not translatable. So for us to be able to relearn our language is also going to help us understand what those laws are and those stewardship measures, as well as what our stories are and what those kind of core fundamental elements of its meaning and its practice and its application is going to be. And so I think for the context of this discussion, it's just really important to note and underscore how language then I think needs to be integrated within new forest management regimes. And it's just also a part of our ability to co-learn and develop innovative ways in which we see the land. For one. So as we know, like I think just in general, like we find 25 different ways to try to spin off and greenwash our ability to continue harvesting. But there's in Daketh, like that just doesn't really exist. You say things simply. And I think that's for many people who work cross-culturally with Indigenous people, and especially with elders, like elders will always ground the conversation by saying something very simply. And so like I always use that other example around like our stories of how the trees used to talk to each other, where at one point like they used to speak to each other, but then those connections got disrupted, and then because we disrupted their natural like those natural laws at one point, and then now they only talk to each other underground. And then that kind of speaks to more Western science, in which many of you folks here can probably relate to. And that's, again, I think it's encoded. So Indigenous knowledge is encrypted knowledge. And in order to decrypt Indigenous knowledge, you have to live those laws and live those practices and learn that language. And, I think those who name claim, and is a big part of like Western modalities, and it's the ways that it continues to usurp power and continue to manage, is done and operationalized through how people speak about the land. And so I think there is an importance for that reinvestment into languages itself. So hopefully that kind of answers the context as to what he was looking for.
That's great. Thank you very much, Seraphine. This is a question for Dominick, and we had a variation of this question from multiple people, and I know you sort of spoke to this a bit in your presentation, but maybe you can elaborate. So the question is, Ministry of Forest sources in the Kamloops timber supply area claim that the level of harvest on recent large fires has been no more than 10% of the total volume available. Would this not be within the range of variability on the landscape to not really compromise biodiversity?
Yeah, great question. I think I did cover it with those real quick examples that I was flashing on the screen. I mean, I hear this all the time. And so the way that this number is derived is you take the entire burn perimeter and you say, oh, well, that was 500,000 hectares and we're only going into 20,000 hectares. How could that be a significant impact? So I think percentage is the wrong way to look at this. You've got to look at it from the context. Context is so important. Scale is so important in ecology. That is really what governs biodiversity and impacts. And so if all you're doing is looking at percentages, you miss context, you miss scale, and you don't see that the logging is really heavily concentrated in the areas that have the highest conservation value. It's targeting the biological legacies. This is not a random 10%. This is a concentrated 10% that is degrading, even if the actual number is small relative to the size of the perimeter that burned.
Okay, that's great. And I'm going to stay with you if that's okay just for a minute, because I have another question that has been asked sort of in multiple different phrasings. But the essential nature of the question is, given the choice between getting our annual allowable cut from judicious, and that's a quote, judicious salvage harvesting, or merely logging more greenwood, which is a better choice?
Wow, you know, that's like, should I take the suicide pill or the electric chair? I mean, you can't put lipstick on a pig. They're both really bad logging practices. And the projects that I work on, the first and foremost thing that we do is we want the high conservation areas off the table. Primary forest, there's so little left. I mean, Karen's work in BC shows how little of the old primary forest are left, and whether they burn or not, it's still important. So I just think that we have got to reduce our logging footprint on a smaller timber base by going into areas that are already designated for logging, and then also doing some restoration through pro-forestation to recover some of that damaged ecosystem, because you're down to 1 to 3%. There's no way you can sustain that unless you have also a restoration agenda. And, we also have to think about our wasteful consumption footprint. I mean, we're 8+ billion people wasting a lot of resources around the planet, and we're running out of natural areas. There's only like about 30% of the world's total forest cover remaining in primary condition. And once those are gone, they're irreplaceable. And countries generally get to that point of reducing their impact on primary forests, but not until they've almost completely extinguished the primary forest areas, and it's not economically feasible to get into these remote places to get the last slivers of primary forest. So get ahead of this now, transfer the industry over to smaller logging footprint that's already designated for logging, save the primary forest, recover areas through pro-forestation, and reduce our wasteful consumption while looking for alternative wood fiber sources. It has to be comprehensive. We're in a global biodiversity and climate crisis with very little sand left in that hourglass. And I'm a grandfather, and I worry about those 7 generations coming.
Yeah, okay. Thank you very much. Thanks, Dominic. Karen, this is another one for you, and I'll just read it because it's pretty succinct. Is the science that Dr. Price discusses being ignored by the Provincial Forest Service and the government?
Yeah, that's a good question. It's being avoided. So, I mean, I will give a bit of a longer answer that right now there are some really great people in the government, and particularly the government has shifted. There are a lot of young, mostly women, I will say, the people that I've met who are really up on this stuff and they know what's going on. Unfortunately, they're not in the positions of power, and the machine is still being run by the old crew of dinosaurs who are really bought into the status quo. And so even though I've been meeting really great people who are trying to change it, the inertia of changing this massive machine is incredible. I mean, what I will say is that that's not the way it's going to happen. And I think that Seraphine was really getting at this, that the way this is happening is not going to be the top down. We really can't wait for the provincial government to do it, because they're not. And even the people that are trying are failing. But what we need to do, and where I actually get hope, we need hope these days, is from these community projects. It's from working with nations, working with communities on collaborative projects where they can go out to the land, where there's people who are connected to the land, and they can say, this is where the valuable places are. This is where the productive stands are. These are the conservation cultural areas. And then they can map that in really great, everyone stands around these. It's not a GIS thing. We'll stand around maps and we draw things and everybody talks about where they got their moose. And that way, there's knowledge sharing that then comes out with a plan that's made on the ground. So I would say the government, there are people that are trying, they're not going to change in time. So really the change has to come from the bottom up.
Okay, thank you very much, Karen. So I think we have time for 2 more questions, and then we'll probably have to wrap it up. I'll ask the 2 questions, and then I think Michelle is going to sort of say a few last words, including what will happen with all the questions we didn't have time to get to with the panelists tonight. So I have one more question for Phil. The question is, how much does salvage logging contribute to BC's economy?
Like so many things, I don't think we have the statistics that break things down in useful ways. Just like it took an extra effort of Karen and her team to figure out how much naturally disturbed forest there was in the Dominica. We just similarly, we do not have. It's first of all, it's not even easy to get actual harvest levels from the government. You have to make a special request into the billing system to see how much was logged compared to what the allowable cut was. And that is not broken down by what was salvaged versus what was green trees. So we just don't know.
Okay, thank you very much. And one last one, this is for Diana. And again, it's sort of a 2-part one. So the overarching question is, does salvage logging control insects? We had that question multiple times. And then sort of the follow-up is, you talked about the attack level in slower growing trees. Is it possible that that is simply a mechanical issue wherein slower growing trees have tighter rings and are therefore harder to chew into?
Geez, getting late and going kind of brain dead. The first one was what, very quickly?
Sorry, yeah, does salvage logging control insects?
Oh, no. The salvage logging comes after the insects have long left the tree. It's strictly for economic returns. And even when the trees are alive and infested, you can't sanitation cut them fast enough to keep up, because the drivers that create outbreaks, which is stress in trees, you're not removing. And so you really can't control the beetles either by salvage or sanitation. And the other one was, I'm sorry.
Sorry, no, that's okay. Just whether it's possible that a reduced attack level in slower growing trees might be a mechanical issue, wherein they are slower growing, therefore have tighter rings, and therefore are harder to chew into.
No, actually the beetles don't actually go into the rings. They don't go into the sapwood at all. They just go under the bark into the phloem layer. And so it's not a mechanical issue at all. And the slower growing trees have just as thick a phloem. We measured that as well as the fast growing, which is something a lot of people have claimed is not the case. So there's plenty of food there. It's just that they're not going in. So we're not sure what they're queuing in on, but it's not mechanical as far as ring toughness, because they're not actually, they never go into the wood part, the sapwood.
Okay, thank you very much, Diana. Thank you very much to Seraphine and to Dominic and Phil and Karen and Diana for sticking with us and answering these questions. I'm just going to turn it over to Michelle for a few minutes to wrap it up. Thank you.
Thank you so much, everyone. So we will take all the questions that you've asked today and do our best to get them answered and posted on our website, the Conservation North website. On behalf of our 4 groups, I would like to thank the panelists for your generosity in speaking to us tonight. The presentations are rich, educational, and inspiring. All the panelists will be receiving a gift made by a Lheidli artist, which Lheidli are the nation that are here in Prince George. Good night, and thank you everyone for attending, and to all the panelists.